really realizing it. We knew that we had to find the vertex to see where it started, right? That's going to determine how much up and over we have to go from that starting point. That is our transformation. It's how much your parent function changes. So you know the parent function of something is the original equation with no changes made to it, right? Okay, so we're going to do this for a linear function first, since you're more familiar with our linear function. That's just the diagonal line. So that's where we're going to start. So it says right here, our parent function for linear equations is the line y equals x. So remember, this is like y equals mx plus b, right? Okay. So there is no plus b on there, right? So that means it just starts where? At 0, 0. Good. And there is no number in front of x, so it must just be 1. So we have a slope of 1. So up 1 and over 1 in the positive direction. Okay, and so this is the parent function y equals x. Okay, and then if you notice, there's a bunch of equations listed under it with small changes being made, right? The only difference between the first one and the second one is that there is a negative in front of it, right? Okay, so if I got out my graphing calculator, which we may want to do instead of having to draw all these on top of each other, there's my parent function, and here is that second equation, right? So y equals x, y equals negative x. I'm going to graph these on here so we can compare them. So the blue one is the original. The red one is what happened when I put a negative in front. So what happened there? Right, it flipped, or it reflected. Good. Oops, I'm running the wrong one. So the change that was made when we put a negative out in front is that it was reflected. You can also graph that on here if you want, but if you notice there's a lot, so you're going to have a bunch of lines on that paper if you do it on your paper instead of your calculator. Okay, my next equation, it is x plus 3. So I'm going to go back in my graphing calculator. I'm going to leave the parent function, because that's what we're comparing all these to. But I'm going to make my second equation x plus 3, just like this one. And then I'm going to graph it so we can compare them. So the blue is the original, the red is the new one. What change was made there? Right, it just went up 3 places, right? So this one shifted up 3. Okay, without even graphing it, we probably have a pretty good idea of what x minus 3 is going to look like, right? What's it going to do? Right. So I could go in here and change that to a minus 3, and it does really just shift it down 3 places. So here we are shifted down 3. Okay? Alright, the next equation is 3x. So remember, we're comparing all of these to the parent, right? So I'm going to go in my calculator, and I'm going to change that second equation to 3x so we can compare. So what do we notice about the red one? Right, it's a lot steeper, right? It's increasing at a much faster rate. Good. So here we might call that steeper or less steep, or we could say that it was stretched upward, right? So we might say stretched by 3. equation I'm comparing is 1/3 of x. If you're going to type this in your calculator, do make sure you either alpha y equals or put in the 1/3 in parentheses so that it doesn't accidentally put the x in the bottom. So what do I notice about the red one this time? What's the difference between the blue and the red? They started at the same point. Alright, it shrunk, or it became less teeth. That's exactly right. So, I would say this one had a shrink by 1/3. Or became less teeth, we might also say. Okay, so what we should be able to take away from this is depending on where they put some number, it's going to affect the change in different ways, right? So, we said if you put a negative out here in front, what did that do? What did that do on the equation that had a negative? It reflected it, right? Okay. And then the m. The m is the two that we had last. So there was a 3 or a 1/3. So depending on what the number is, what is that going to do to our graph? Right. Changes our slope. It changes, it might make it stretch, it might make it shrink, it just depends on the number. So the m is going to control stretch and shrink. Alright, and then this plus b right here, that's like our x plus 3 and x minus 3. What did those numbers do to our graph? Right, they moved it up and down. Good. Okay, so depending on where a number is, without ever even graphing it in your calculator, we should know what change is being made if we can remember what each piece means. So a negative is going to reflect it. A bigger number for m is going to stretch, but a smaller number like a fraction will shrink it. And depending on what this number is out here, positive or negative, it's going to shift the whole graph either up or down. Okay, and then it does ask for the domain and range given in set and interval notation. Well, on all of the graphs, goodness, what is going on? Okay, whether it's slanted this way or this way, both ends kept going forever, right? Except those arrows on the ends. Okay, so domain, those are my x values. Is this ever going to stop going this direction? Is it ever going to stop going that way? So we talked about domain and range back in Unit 1. Our set notation would say this is going to go on forever. When we talked about those sets of numbers, all real numbers. Okay? My range, so that's a y value. Is it ever going to stop going up? Is it ever going to stop going down? So it's also all real numbers. Okay, we also had a second way of writing that, interval notation. That's where we gave actual values. Well, if we said that it's going to go to the left forever, that's into the negatives, so negative infinity. And we said it's going to go to the right forever, which would be off to positive infinity. And we said it's going to go down forever and up forever. So that would also be from negative to positive infinity. Okay. So this with the information that we do already know. Now that we've written all this down, we're going to make the same comparisons for our absolute value function. So if you'll flip to the next page, we're going to do the same thing, but for the absolute value of parent function. So you can do this in your calculator too. Remember to pull up absolute value in your calculator. You press math, and you go over to where it says NUM. Choose number 1. ABS stands for absolute value. And then it'll put those bars. Okay, and we're just talking about the parent function first. The absolute value of x. It makes that V shape, right? So we can see that it's going to start at 0, 0, which makes sense, right? Because there's no h and there's no k, so they must both be 0. And then our a is what tells us up and over. Nothing out there, must be 1. So we graph the right and make the left look the same. Okay, so here is my parent function for absolute value. Our next one has a negative out in front. What change do you guys think that's going to make to this graph? Right, reflect it. It's going to flip it upside down. We've done this before when we were graphing, right? So you could still put this in your calculator. Make sure your negative's out in front. And it is. It's the exact same graph. It's just that it flips upside down or reflected. Okay, so the change here was that it was reflected. Okay? Alright, my next graph is the absolute value of x plus 3. So that's normally my k, right? Or my y value. Y tells us up and down. So that should be a hint for us on what that's going to do to our graph. But you can always check it in your calculator. So the only difference between those two is that what happened. Good. And we probably already have a pretty good idea of what the absolute value of x minus 3 is going to look like. What do y'all think? Good. So we graph it, and that is exactly what happens. Yes? Okay. Remind me at the end of class, and I'll switch those batteries. Okay. So here, we just shifted down 3. On the next one, the A value is what's changing, right? It's been 1 so far. Now it's telling us it's 3. So what do you guys think that the effect is going to be on our graph? What? So it's going to be just like on the front. It's going to stretch it up, right? So if I go in here, I'd have 3 times the absolute value of x. Just makes it skinnier, right? Stretches it up tall. So stretch by a factor of 3. So what do you think the 1/3 is going to do? Good. So this is going to make it shrink by 1/3. And again, I can do that in my calculator. I would just come down here, 1/3, and then absolute value of x. right? It makes it wider or shrinks it down, right? Okay. And then we have two more. So normally inside of there we call that our h, right? To see what it really is, we have been setting it equal to 0 and solving. So if it says x minus 3, if we were to solve that, what does it really become? Positive 3. And remember, inside is that's our x value in the coordinate for our vertex. So that should be a shift of our x value. So on this one, if you are typing this in your calculator, you do have to put the minus 3 inside with the x. So x minus 3 all inside the absolute value. And move it to positive 3, right? So don't let that trick you. It says minus 3, but we should know that really means it's going to go to positive 3. So here, we shifted right 3 places. And this one says positive 3, but we know when we set it equal to 0, it becomes negative. So really, this is going to shift where? Good. So, just like that linear function, depending on where the number falls in the equation, it's going to make different changes to our graph. So, we said if we have some negative number out in front, what does that do to our graph? Reflects it. Good. Okay, and depending on what our A is, it might be a number like 3 or a fraction like 1/3 or 1/2. What is that going to do to our graph? Good. Okay. Okay, and then the h. So the h is the one that's inside of the absolute value, right? So those are like our last two equations. What kind of change did that make to our graph? Right? So this one is going to shift it left and right. But make sure we remember it's going to be opposite of what it says, right? Okay, and the very last piece is k. So that's that number out there on the end. What kind of change did that make? Up and down. Okay, so if we can remember all these things, we don't even have to graph it. I could give you an equation, and you could tell me what it's going to look like. You're going to know it's going to get skinnier by a factor, or stretch up by a factor of 3. It's going to be moved to the right 7, right? You should be able to tell that just from looking at the equation. All right, it does also ask for the domain and range. So here it's our function. All of them were facing upward just like this, maybe move left, right, up, down. The only one that wasn't was if it was negative and it looked like this. But either way, my domain is my x's, right? In either graph, are these ever going to stop going to the left? Will they ever stop going to the right? So again, my domain is all real numbers. Or that could also be written as going from negative infinity to positive. Okay, go Brent.
Pardon me.
Alright, so for our range, that's our y values, right? That one is a little bit tricky because in this picture, it goes up forever, right? But does it go down? It stops right here. If it's flipped upside down, it goes down forever, but it doesn't go up forever, right? So it's either going to go down forever or up forever, just depending on what your equation is, right? So this is y values we're talking about. So y is either going to be going up or getting greater forever, depending on where it starts, right? So for example, the parent function starts at 0. But where did this one start? 3. So it would have started up here. So it would just be getting bigger from 3, right? So your range on these is just going to depend on where it starts, which is determined by the k value, right? That one out on the end. So it could either be greater than k, or if you have a negative out in front and it's pointing down, your y could be getting smaller than k. Those are our only two options here. So that could also be written as saying that it either goes down forever and stops at k, so that would be from negative infinity all the way up to k. And remember, we put a point that's actually real with a bracket because it can be included. Or we can say the lowest point is k, and it goes off to infinity. So it just depends on which way your graph faces. So your domain is always going to be all reals, or negative infinity to positive infinity. This part changes depending on the picture of your graph. Okay? But what's most important is that we remember what each piece does. Okay, so keeping this in mind right here, let's flip it over onto the last page. It says, how does what you learned today regarding the h and k relate to what we learned in the past few days with the vertex being h and k? So in the past, we knew that h and k formed the vertex, right? We knew that that was like our starting point. But now we also know that that's going to control left and right as well as up and down shifts. So we knew HK was the vertex, and now we know it controls left and right, and up and down shifts. Also, K does help control our range, right? We didn't just talk about that as well. Also, K determines range. Okay, so remember, negative out in front will reflect. The number out in front is either going to stretch or shrink. Inside is going to be left and right. On the end is up and down. Okay, so then they give us some examples here and ask us to describe the transformations that are being done to the parent function. Okay, so these first couple are linear. So that's our diagonal line ones. Okay, so there's no negative, right? So it hasn't been reflected. But that 3, what is that going to do to our graph? What is the number out in front? Good. So this will stretch by a factor of 3. The next thing we come across is a negative 2 on the end. What's that going to do? Good. Shift down 2. 2, we have a negative out in front. What is that going to do? Well, just the negative itself, what is that? Reflects it. Okay. Okay, now, the negative tells us reflection. Now we don't care about the negative anymore. Just the 4. 4 is a big number, so it is going to stretch. So the only thing that can make it shrink is something between 0 and 1, like a fraction or decimal. So stretch by a factor of 4. Okay, and what does that last piece on the end tell us? Good. Okay, on number 3. So there's no negative, we don't have to worry about reflection. 2/5. What's that going to do? Right, smaller than 1. So shrink by a factor of 2/5. Then what else? Good. Shift down what? Okay. Number 4. Negative in front, what does that tell us? Good. Okay, 5/3. Is that bigger or smaller than 1? Bigger, so it's a good. So stretch by a factor of 5/3. What's the last piece tell us? Good. Okay. Same idea, but starting with number 5, we have the absolute value, so the V-shaped ones. So remember, these can also be shifted left and right if there's something inside the absolute value. Okay, so out in front, no negative. What does that 2 do? Good. Okay, that +3 is inside the absolute value. So what is inside the absolute value going to do? Move it left and right, and it's opposite of what it says. So it says +3, so you would think that would mean to the right, but it's really going to go to the left. And then that negative one on the end is going to shift down 1. Okay. Number 6. What do we notice first? Negative, and that tells us that it's reflected. What's the 3 do? Good. Okay. And that -2 is inside, so opposite of what it says. Where is that going to move us? Good. plus 5 on the end. Okay, number 7, we have 1/4 out in front. What's that going to do? So shrink by 1/4. Okay, and what's the -2 in the absolute value going to do? Good. And then the -1 on the end. And then 3/4, again, that's smaller than 1. So another shrink. So there's nothing to move it left or right. This is nothing inside. But the -1 will tell us to shift down 1. Alright, last one. The negative in front tells us good. What about 5/2? It's bigger than 1. Good. So it is going to be a stretch. Okay, and then what about that +5? What's that going to